Hello and welcome. Today we will program this tic-tac-toe game in C# using WPF for the UI. We will start by programming the game logic, then we will set up a functional UI, and finally we will add some animations to make it look better. Let's get started. I have opened up Visual Studio and created a new WPF project. We start by setting up a few simple data classes for the game. First, let's add a player enum. We give it 3 enum members, none, X and O. We will use this class to store which player's turn it is, and also what the content of each square in the 3x3 grid is. Next, we will add another enum called winType. It needs 4 enum members, 1 for each way a player can win. As you probably know, a player can win the game by marking every square in a row, column, or one of the diagonals. The main diagonal is from the top left corner to the bottom right corner, and the anti-diagonal is from the top right corner to the bottom left corner. We also need a small class called winInfo. It simply holds a winType and an integer. This class will supply information about how a player won the game. If a player won by marking a row or column, the number integer will store which one. For example, let's say that a player won by marking the bottom row, which is row number 2. In that case, we would create a winInfo object with type set to row and number set to 2. The reason why we need this information is to display a green line in the correct position when a player wins the game. Alright, the final data class we need describes how a game ended. I call it GameResult. It just needs to store the winning player and a winInfo object. If the game ends in a tie, we will set the winner to none and we won't supply a winInfo object. Great, let's write the logic for the game. It will be contained in a GameState class. Here we will store the 3x3 game grid as a 2-dimensional player array. We also need to know which player's turn it is. How many turns have passed. And whether the game is over or not. Next, let's define a few events. Don't worry if you haven't encountered events before. I will explain how they work as we go. We have to import the system namespace. Our first event is called moveMade. We will raise this event when a player has successfully made a move. The receiver of the event must define an event handler with type actionInt. This is simply a method which takes 2 integer arguments and returns void. The 2 integers will be the row and column of the square that was marked with the move. The next event we need is called gameEnded. This event will supply receivers with a GameResult object when the game has ended. Finally, we will add a GameRestarted event which is raised when the game is started over. Let's create a constructor which initializes the game grid and sets the current player. The game grid contains player.none in every entry by default, because that is the first enum member we defined. Traditionally, player X starts the game, so we also go with that. For clarity, I will also set turns passed to 0 and game over to false. Okay, now we need a few helper methods. The first one returns whether or not the current player can mark a given square. They can if the game is not over and the square is empty. The next method is called isGridFull. The grid must be full if and only if 9 turns have passed. Next, when a move has been made, we need to switch the current player. You could also use a conditional expression for this if you are a one-liner type of person. We must also know when a player has won the game. So first, we write a little method which takes an array of square positions and a player. It should return true if all the given squares are marked by the given player and false otherwise. Now we can write a method to check if a given move won the game. It takes the row and column of the square marked by the current player and returns whether or not that move won the game. If the move was in fact a winning move, the method will provide additional information in the winInfo out parameter. First, we create an array containing the square positions of the row where the move was made. And same thing for the column. The newly marked square could also be part of a diagonal, so we also create arrays for the diagonal positions. If every square in one of these arrays is marked by the current player, then that player has won the game. We will use our rSquaresMarked method to check if that is the case. Let's start with the row. If rSquaresMarked returns true, we know that row R is full. So, in the winInfo object, we set type to winType.row and number to R. And return true. We do the same thing for the column squares, but in the winInfo object, we set type to winType.column and number to C. Next, we check the two diagonals. There is only one main diagonal and one anti-diagonal. So if any of them are marked, we don't set the number property in the winInfo object. If we make it past these 4 if statements without returning, then the given move did not win the game. In this case, we set winInfo equal to null and return false. Next up, we will create a method which checks if a move ended the game. It takes the row and column of the square marked by the move and returns whether or not that move ended the game. If it did, then we supply additional information in the GameResultOut parameter. First, we check if the given move won the game. If it did, then the winner is the current player. So in the GameResult object, we set winner equal to the current player and pass the winInfo object from didMoveWin. The game is over in this case, so we return true. If the given move didn't win the game, but the entire grid is full, then the game ends in a tie. In the GameResult object, we set winner to player.none and we don't provide any winInfo. But the game is over, so we return true. If we make it past these 2 if statements, the game is not over. So we set GameResult to null and return false. That was quite a few helper methods. Now it's time to chain them all together, and we do that in a public makeMove method. It takes a row and a column as parameters, and if it's possible, the square at that position will be marked by the current player. First of all, if the move cannot be made, then we return without doing anything. If the move is possible, we perform it and increment turns passed. Then we check if the move ended the game. If so, we set game over to true. And then we should invoke the move made event with the given row and column. This will crash if there is no event handler registered for the move made event. We can make sure that there is an event handler by comparing it to null like this. But the null check is a little verbose, so let's use this equivalent syntax instead. It does the same thing. And since the game has ended, we will also invoke the gameEnded event. If the move did not end the game, we change the current player and invoke the move made event only. Now we just need one final method which resets the game state. Here we replace the game grid with a new array which contains only player.none by default. And the current player will be set to player.x again. Turns passed should be 0. And game over should be false, of course. And finally, we invoke the game restarted event. Alright, that does it for the game logic. Let's import some assets and then we will get started on the UI. We start by creating a folder for the assets. Open up the Solution Explorer, right click on your project, select Add and click New Folder. It doesn't have to be named Assets, but that's what I name mine. Here are the assets I have made for this project. It looks like some of the images are blank, but if I select them, you can see that's not the case. There is an image of the grid and an icon. We also have a bunch of images for the X and O mark at different stages of drawing. We will turn these images into animations later. Click the link in the description to download the assets. Feel free to use them as they are, or modify them in any way you want to. Of course, you can also create your own assets. To import them, just drag and drop them into the assets folder. Then select all of them. Right-click, select Properties, and make sure that Build Action is set to Resource. Now we are ready to write the UI. We start by opening the file called app.saml. And by the way, you can close the files we have created so far. They are finished. In this file, we will define a few color resources. The background color will be an orange color with hex value F48A2E. We will also define a button color with hex value FFB966, which is a brighter shade of orange. And finally a line color with value 01 FD0A, which is a bright green color. Great. Now we will open main window.saml. First of all, let's change the window title to Tic-Tac-Toe. And I want the font to be Segoe UI Light. For the background, we will use the background color resource we defined. For this layout, we need 2 rows. The top row has height set to auto, and the bottom row will use the remaining height. In the top row, we will show which player's turn it is. I want a text block with the text player, and next to that, an image containing either an X or an O. Let's add a stack panel with the name Turn Panel. The orientation should be horizontal, and I want it to be horizontally centered. Inside the stack panel, we create a text block with font size 54 and text set to player. Next to that, we add an image named player image with the source set to assets/x15.png, which is a fully drawn X. It is obviously too large, so let's set the height to 75. Much better, but the text is not quite aligned with the image, so let's move the text up a little bit. Great, the turn panel is now done. In the bottom row, we will display the 3x3 grid. For that, we will add a canvas. I have named it Game Canvas and set the width and height to 300. Inside that, we will add a uniform grid named GameGrid and give it the same width and height as the canvas. And since we need a 3x3 grid, we will set rows and columns to 3. We also need to register an event handler for the mouse down event, so we know when the player has clicked somewhere on this grid. The background for this grid will be the grid image in the assets folder. That's it for the game grid. We will add some images to it from the code behind in a minute. But first, we need to add a line to the canvas which we will show when a player wins. I have called it line and given it the line color we defined earlier. The stroke thickness is set to 10 and it is rounded in both ends. The line should only be visible when the game is over. So initially we set the visibility to hidden. The last thing we need here is an end screen where we will display the winner. It should also contain a button for restarting the game. Let's create another grid for it. This one is called end screen and it spans both rows. I have set the background to our background color. This is just so we only see the end screen in the designer. Inside the grid, we add a stack panel. I want some text on the left and an image on the right, similar to what we did for the turn panel. So let's add another stack panel, this time with horizontal orientation. Inside that, we will add a text block named result text and set the font size to 54. The text will be controlled from code, but let's set it to winner so we can see how it looks. Next, we add an image named winner image with height 75. Again, so we can see how it looks, I will display the fully drawn X. Just like for the turn panel, the text and the image don't seem to be perfectly aligned. So I will give the text block a small margin. The final thing we need is a button for restarting the game. Finally, let's register an event handler for the click event. And because the end screen should not be visible until the game is over, we set its visibility to hidden. Now we navigate to the file called mainwindow.saml.cs, which is known as the code behind. The game and the UI will be controlled from here. As mentioned in the beginning, we start by creating a functional UI and then we will add some animations to make it look better. Alright, we need two image sources, one for player X and one for player O. I will store them in a dictionary so we can conveniently look up the image for a given player. If you have seen my Tetris tutorial, you know that I usually load images using a relative URI. But for some reason that wouldn't work with the animations we will create later. So in this video we load images using an absolute pack URI, as you can see here. x15.png is the fully drawn X and o15.png is a fully drawn O. Next, we declare a 3x3 image array which will store one image for each square in the game grid. And of course we need a game state. Let's create a method which will set up the images for each square in the game grid. it will simply loop through each row and column. Then we create a new image, add it to our uniform grid called GameGrid, and store it in our image controls array. Recall that GameGrid is a uniform grid with 3 rows and 3 columns. This means that it will automatically position and scale our images the way we want. And now we have this image controls array where we can easily access an image in a given row and column. Setup GameGrid should be called in the constructor after initialize component. Remember that we defined 3 events in the GameState class. Let's add event handlers for those 3 events so we can respond appropriately when they are raised. The event handler for the moveMade event will receive the position of the square that was marked. The gameEnded event handler will receive a game result object, and the gameRestarted event handler won't receive anything. Okay, let's hook up these event handlers in the constructor. Now, when an event in the GameState class is raised, our event handler is called automatically. Great, but the game still does nothing. We have to write some code in the event handlers. We start with GameGrid mouse down, which is called when the GameGrid is clicked. First, let's create a variable for the size of a square. It will be 100 because our GameGrid has width and height set to 300. Next, we get the clicked position relative to the top left corner of the GameGrid. And remember that in WPF, the origin is the top left corner and Y values grow from top to bottom. We want to figure out which square the user clicked on. To get the row, we divide the Y coordinate of the click position with the square size and cast the result to an integer. And similarly, we can get the column like this. Casting to an int will round down to the nearest integer, which is exactly what we want. Finally, we call GameState.makeMove with the row and column as parameters. Now we just have to update the UI when a move succeeds. So let's add some code to onMoveMade. Remember that this method will automatically be called when a move has been made. First, we check which player marked the given square. Then we set the source for the image control in that square. And update the source for the player image in the turn panel so it correctly shows who the current player is. Let's start the game and see what we have so far. When I click on a square, it is marked, and the image showing the current player is also updated correctly. But when a player wins the game, nothing happens. So let's fix that. First, we will write a little method which hides the game screen and shows the end screen instead. It takes a string, which is the text that should appear on the end screen, and an image source, which is an image of the winning player. Here, we will hide the turn panel and the game canvas. Set the result text and winner image source. And then show the end screen. we have to call this method from onGameEnded. First we check if the game ended in a tie. If it did, then the winner is saved as player.none. In this case, we call transition to end screen with the text "it's a tie" and null as the winner image source. If we do have a winner, we pass the text winner and an image of the winning player. Okay, let's test it out. Well, it seems to work, but it transitions instantly, which is not ideal. So let's make onGameEnded async and wait for 1 second before the transition. Much better. Let's also see what happens when a game is tied. Great. It is starting to look like a tic-tac-toe game now. But this play again button doesn't work yet. So we will fix that now. This method, called button click, is invoked when the play again button is clicked. Here we will call GameState.reset. We also need a method which takes us from the end screen back to the game screen. When the game is restarted, the onGameRestarted method will be called. The grid in the game state will be empty, so we will set the source of every image control to null, so the grid also appears empty on the screen. Then we update the player image and call transition to game screen. Now we can play the game over and over again. There is one more feature that is pretty important for the feel of the game. When a player wins, we want to show a line through the row, column or diagonal fully marked by the winner. Let's create a method which takes a winInfo object and returns the start and end point of that line. Let's save the square size and add a margin variable which is equal to half of the square size. From the data stored in winInfo, we can determine where the line should appear on the screen. First we handle the case where the game was won by marking a row. In this case, the line should be horizontal, so both the start and end point will have the same y coordinate. This is at the vertical center of the row. Because the line should span the entire width of the grid, we return these 2 points. The column win case is handled similarly. For the main diagonal, the line should go from the upper left corner to the lower right corner. If we make it past these 3 if statements without returning, then the win type is anti-diagonal. In this case, the line should go from the upper right corner to the lower left corner. Perfect. Now we can write a method which actually shows the line. First, we get the start and end point. Then we use those points to set the start and end position of the line we added to the canvas earlier. And make the line visible. We will call showLine from onGameEnded. After the line is shown, we will wait another second before going to the end screen. That looks really great, but see what happens when we restart the game. We must make sure that the line is hidden when the game restarts. Let's take care of that in transition to game screen. Now it works as expected. But notice that the window for our game doesn't show up in the center of the screen. It is easy to change that if you want. We just have to go to mainWindow.saml and set window startup location to center screen. Now the window appears in the center of the screen. But look what happens when the window is resized. Our UI doesn't scale very well. You are gonna love how easy it is to fix this. All we have to do is wrap the main grid in a view box. If you look in the designer on the left, you can see that there is no space between the bottom of the window and the game grid. So let's give the canvas a small margin. Now the game scales perfectly. Now I think it's time to add some animations to this UI. Let's head back to the code behind. First, we will create animations for the X and O mark, so it looks like they are drawn on the game grid when a player makes a move. We will achieve that by animating the source property of our image controls. There is no image animation class in WPF, so we will be using object animation using keyframes. Just like for the image sources, we will store the animations in a dictionary. Right now both animations are empty, so let's create a setup animations method. I want both animations to last for 0.25 seconds. Next, we have to load the images from the assets folder and add them to the animations. There are 16 images for each player, named X0 to X15 and O0 to O15. So we need a loop with 16 iterations. Inside the loop, we load the next image for the X animation. Once it's loaded, we create a discrete object keyframe containing the image and then add it to the X animation. We do the exact same thing for the O animation. This method should be called in the constructor. Now we just have to change onMoveMade a little bit. Instead of setting the source here, we apply one of our animations instead. We specify that we want to animate the source property using the animation for the player who moved. And it works. But there is one tricky thing we have to fix. When we restart the game, the grid is not cleared. This is pretty confusing, right? In onGame restarted, we clearly set the source for all image controls to null. The thing is that our animations are still in charge of the source for the images we have applied them to. We have to explicitly cancel them like this. After that, we can set the source directly. Now the grid is cleared when we restart the game. Next, let's make the transition between the game screen and the end screen a bit more smooth. To do that, we add two more animations of type double animation. The first one will be called fade out animation, and it will be used to animate the opacity of the game screen and the end screen. The duration is set to 0.5 seconds and it should produce values from 1 to 0. Similarly, we will create a fade in animation which will produce values from 0 to 1. The fade out animation will be applied in a fade out method. It is async and takes a UI element parameter. First, we begin the fade out animation on the opacity property of the UI element. Then we wait until it is finished. And after that, we hide the UI element. Let's also create a fade in method. We make the UI element visible. Begin the fade in animation. And wait until it is finished. Now we can utilize these methods in our transitions. We will make transition to end screen async. And instead of changing the visibility directly, we use fade in and fade out. Transition to game screen will be changed in the same way. Now we just have to await them in onGame ended. And same thing in on-game restarted. Let's see how it looks. Now there is a smooth transition between the game screen and the end screen, but this allows the player to restart the game multiple times, which is not ideal. So let's go to the event handler for the play again button and change it so the game state is only reset if the game is over. Now it works as intended. Finally, we will animate the line so it looks like it's being drawn. We make show line async and get rid of the part where the endpoint is set. Now we are going to animate the endpoint instead. We need two animations here, one for the x coordinate and one for the y coordinate. Then, after the line is made visible, we apply the animations to the x2 and y2 property of the line. And finally, we wait for the animations to finish. That's it. We just have to await the call to show line in on-game ended. Let's check out the result. Beautiful. The final thing we will do is add the icon. So open up the Solution Explorer, right click on the project, click Properties and set the icon to assets/icon.ico. That's it. We have now built this nice tic-tac-toe game. Thank you for watching. I hope you liked this video. If you did, then consider leaving a like and subscribing to my channel.